And good day to everyone. So in this video, I am going to discuss the checkpoints from topic 1, okay, especially for checkpoint from the subtopic of concentration of solution. So, uh, so we have checkpoint 17 and the following checkpoint, okay, that we haven't discussed during our lecture last time. So in this video, I'm going to discuss this checkpoint. Okay, question 1. Calculate the mass of solute and mass of solvent from each prepared solution. So these are the given solution. Okay, so they are given in terms of percent by mass, in terms of molality and also in terms of molarity. Okay, so what you need to do is to calculate the mass of solute and mass of solvent for each of these solution given. And the density is given. So the density for all of the solution is 1 gram per mil. Okay, assume the density of the solution is 1 gram per mil. All right, so let's discuss A first. All right, so this is A. 125 gram of 1% by mass of sodium nitrate solution. So you must be able to interpret this information. Okay, so this 125 gram represents the mass of the solution. Okay, this represents the mass of the solution. This is the concentration given in terms of percent by mass. So this can be interpreted in terms of mass. Okay, it can be converted directly from percent to gram. That is 1 gram of the solute, in this case sodium nitrate, is 100 gram of, in 100 gram of solution. In 100 gram of sodium nitrate solution. So please bear in mind that solution is already inclusive of the solute and the solvent. Okay, all right. So this is the information given. So 1 gram of solute in 100 gram of the solution. But what we want is the mass of solute in 125 gram. Okay, and also the solvent for 125 gram of solution. But what have been given to us is in the form of 100 gram of solution. So for 100 gram of solution, we have 1 gram of solute. So how about 125 gram of solution, right? Okay. So we use this information. Okay, so this is the information given from the question. So 125 gram of sodium nitrate solution. So this is the percent by mass provided in the question. Okay, so this could be used as our conversion factor for our dimensional analysis method. Okay, all right, so we have gram of sodium nitrate solution. That means here should also gram of sodium nitrate solution. Okay, these two should have the same unit. So this can be cancelled out. So up here we have 1 gram of sodium nitrate. This again, okay, is obtained from the information given. Right? So from there we can calculate this is the mass of the solute for 125 gram of the solution. Okay, so this is the mass of the solute. All right, so we are done with mass of solute. Next, the question is also asking for mass of solvent. Okay, so since we have the mass of solution, 100, which equal to 125 grams, okay, we know that mass of solution is equal to mass of solute plus mass of solvent. Right, so we have determined the mass of solute just now, so we can calculate for the mass of solvent. So the answer is 123.75 gram. Okay, all right, so now let's move. Okay, this is the answer provided in the slides. Okay, alternative to this answer just now, okay, you can also use this as your answer, okay, where we have the formula of the mass percent itself. Okay, the formula of the mass percent itself. All right, so percent by mass is equal to X gram of sodium nitrate over 125 gram of solution. Okay, times 100. So this is the formula of percent by mass. So we have the percent just now, 1%. Okay, but this time around we are looking for the mass of solute for 125 gram of solution. So the mass of solute is now X. Okay, so we can calculate the X. So we have this mass of solute, and then we can minus with the mass of solution to find the mass of solvent. Okay. All right. So moving on to the second question. So I have prepared this answer. Okay, and we also have alternative to this answer. Okay. All right. So B. This is the information given for the solution. So 301 gram. So this represents the solution itself. Okay, 301 gram of 0.115 molar of C2H6O2 solution. Okay, so please bear in mind this represents the mass of the solution. And the concentration is given in terms of molality. Right? So what we want is the mass of solute and the mass of solvent. Okay, so this is what we are looking for. All right, so what can we use? Okay, what can be obtained from the information provided? Okay, all right, so we have molality, so we have to interpret that from the value itself. Okay, it means that we can translate ataupun interpret the molar, the M, the small letter M into mole per kilogram. So this is the formula of the molality itself. Okay, so the small letter M can also be interpreted ataupun expressed in terms of mole per kilogram of solvent. Okay, all right. So this is in terms of formula itself. So we have 0.115 mole of solute for 1 kilogram of solvent. Okay, all right. So this is the amount of solute for 1 kilogram of solvent. But what we have here is 301 gram of solution. Okay, so this is solvent and this is solution. So we have to relate these two first. So this is totally two different things. We have solution and solvent. Okay, so this is the mole for 1 kilogram of solvent. How about the mole for 301 gram of solution? Okay, all right. So using the information from the molality, we can calculate for the mass of solution for 0.115 mole of solute. Okay, so we are good. We can calculate the solution. We have to make this information correlate with one another. So this one in terms of solvent, this is in terms of solution. So we need to find the mass of the solution. Okay, all right. So in order to do that, okay, we have the mole of the solute. If we have the mole of the solute from the molality just now, we can convert that into mole. So we can multiply with the molar mass, right? So this is the mass of the solute for 1 kilogram of solvent. Okay, all right. This is for 1 kilogram of solvent. All right. So moving on, to find the mass of solution. Okay, all right. So we have the mass of solute just now. Okay, and then we do not yes, we do have this information. Remember, this is for this 0.115 mole or equivalent to 7.13 gram in mass is for 1000 gram or 1 kilogram of solvent. That means we can calculate for the mass of the solution. Okay, so this is the mass of the solution. The apa nama tu, hasil total of solute and solvent. Okay, so we have the new relationship, okay, that we can obtain from the molality just now. So when the mole just now we have converted into mass, so it is 7.13 gram of the solute in 1007.13 gram of the solution. Okay, so basically the molality just now is 0.115 in mole over 1 kilogram of solvent, right? All right, so when we modify this information, we can also get this apa nama, the modified version okay, which is 7.13 gram of solute. This is in terms of mole, this is in terms of gram, and the kg solvent is converted into solution. So 1007.13 gram of solution. Okay, so these two, they have the same concentration. It's just that in terms of they differ in terms of unit. So we have mole into gram, kg of solvent into gram of solution. Okay, into gram of solution. So this could be our conversion factor for dimensional analysis method. Okay, all right. So this is the information. So now remember, just now the question is given, the values is given in 301 gram of solution. That is why we need this information. Okay, to relate the value given in the solution, right? So we can use a value just now, 301 gram of solution, using this modified version of apa nama tu, from the molality just now. Okay, so gram of solution cancel out. So up here we have the gram of the solute for 301 gram of the solution. So this is the mass of the solute for 301 gram of solution. Okay, all right. So from there we can calculate for the mass of the solvent. Okay, so to calculate the mass of solvent for 301 gram of solution, so we can just simply minus 301, okay, with 2.13 gram. So this is the value, 299 gram of the solvent. Okay, all right. So alternative to the previous solution just now, okay, you can also answer in terms of this by using the formula of the molality itself. Okay, all right. So what we want is to find the mass of the solute and the mass of the solvent. Okay, so this is the information given. So we know that 0.115 molar is equal to 0.115 mole divided by 1 kilogram of solvent. Right, so to find the mass of solvent, 301 gram minus mass of C2H6O2. So this is unknown. Okay, you can use mass of solute plus mass of solute and mass of solvent, or you can simply replace those with X and Y. X and Y. Right? Okay. So assume that mass of the solute is Y gram, and the mass of solvent. Okay, we know that to find the mass of solvent, we can minus 301 minus with Y. Y is the mass of solute. Okay, so we can get the mass of solvent. So this is like the unknown lah that we have defined just now. Okay, so you may use Y and 301 minus Y. Okay, all right. And then from there, okay, kita kembangkan, kita expand the formula. Okay, so mole, to find the mole, the Y gram, the Y is, remember, the solute. Okay, the Y gram divided by the molar mass. Okay, divided, so this is the formula of molality, divided by the mass of solvent in kilogram. Okay, so to find the mass of solvent just now, 301 minus Y divided by 1000, because we want the solvent, the mass of solvent in kilogram. Okay, when we simplify this, this is the how the formula, how the working looks like. Okay, all right, so kita rearrange whatever need to be rearranged. Okay, so this is, okay, kita proceed further. So the mission is to find the Y. So what is Y, right? So we solve this mathematically. So we have this. So 2.13 is the mass of the solute. Remember, Y is the mass of solute. Okay, so once we have this one, we can simply minus 301 minus 2.31, which is the Y, in order to get the mass of the solvent. Okay, so this form, the approach for this solution is to expand from the formula itself. okay, from the formula of the molality itself. But before you could do that, make sure that you define all the unknowns. Okay, so in this case, the unknowns are defined in terms of mass of solute and mass of the solvent. So this is the definition. So we said that the mass of solute is y gram, therefore the mass of solvent can be related as 301, which is the solution minus the solute. And then from there, insert this formula, insert this unknown into the formula of the molality itself. Okay, right. Okay, as for C, okay, so this is the information given: 125 ml of 0.1 molar of sodium nitrate. So for this time around, the concentration is expressed in terms of molarity. Okay, so first, the earliest one, the concentration is expressed in terms of percent by mass for A, and then B we have in terms of molarity, and then C here we have in terms of molarity. Okay, so we have to find the mass of solute and the mass of solvent. All right. Okay, so to find the mass, so this 125 ml represent the volume of the solution. Okay, remember what we want is the mass. So obviously we have to convert this volume into gram. Okay, we have to convert this volume into gram later on. Right? Okay, so 125 mil, remember this is for the solution. So when we translate 0.1 molar is also equal to mole per liter. Okay, it's equal to mole per liter. All right, so I just use 125 mil given. So the 1 liter I convert into 1000 mil so that it can be cancelled out. Okay, you alternative to that, you may convert milliliter to liter directly, and then you can use 0.1 mole sodium nitrate over 1 liter of solution. Okay, either way you should get the same mole. The value of mole should be the same. Okay. All right, so this is for 1 liter. All right, so what we are looking for is for 125 mil. So this is the mole for 125 mil. Okay, so to find the mass of solute, we can just simply times with the molar mass. So this is the mass of the solute. All right, so we are done with the mass of solute. So to find the mass of solvent, okay, so to find the mass of solvent, we need to convert the milliliter just now of the solution into gram. So we have this density given, provided in the question. Okay, so we can convert that into gram. So from we know that mass of solvent can be obtained from the minus product of solution with solute. Okay, right. So this is the mass of solvent. Okay, alternative to that, we can also all right. So this is pretty much the same as what I have previously. Sama saja ini. Okay, they translate from the molarity just now, and then convert into mass, and then to find the mass of solution, you need the density. Okay, so this is basically the same as what we had earlier just now, right? Okay, sama je. Okay, moving on to question 2. Okay, calculate the mass of water that must be added to 5 gram urea to prepare 16.2% by mass solution. So the information is given in terms of percent by mass. Okay, the concentration is given in terms of percent by mass. This 5 gram, okay, is the mass of solute. Okay, you make sure that you define the information given. So this is for either it's for solute, either it is for solution or solvent. Okay, so that must be defined first before you could proceed to the working. Okay, so the question is asking for mass of water or mass of the solvent given the mass of the solute, and this is the concentration of the solution. Okay, we can interpret the mass, the percent by mass in terms of gram or in terms of mass. Okay, 16.2% means we have 16.2 gram of solute, which in this case urea, in 100 gram of urea solution. Okay, all right. So from here we can minus these two in order to get the mass of solvent. Okay, to get the mass of solvent, we can simply minus 100 gram of the solution with 16.2 gram of solvent. Okay, all right. So this is the hidden information that we can obtain from the information from the percent by mass given, from the concentration given. Okay, all right. So so we can so this is okay. So this is the what we call that. This is the mass of solute just now. Okay, what we are trying to look for is for the mass of the solution. Okay, for the mass of the solution. All right, 16.2 gram, the mass is 100 gram of solution. If we have 5 gram of solute, what will be the mass of the solution? Okay, all right, so we can use this. This is from this information. Okay, so cancel out. So we have, this is the amount or the mass of urea solution, the solution itself. All right, so to find the mass of water, so please bear in mind, water in this case is the solvent. Okay, all right, so we can minus the solution with the mass of the solute. So this is your, this is the mass of water or the mass of solvent. Okay, all right, so alternative to this answer, we can also use the formula of the mass percent itself. Okay, the formula of the mass percent itself. Okay, so this is the percentage given. So this is the mass of solute, okay, divided by the mass of solution. But we do not have this information yet. Okay, all right. So since this is the only unknown and the rest are all values, we have all the values already. Okay, we can solve for this mass of H2O. So this is the mass of H2O, right? Right. So that is all for part one. So we have several more checkpoints that discuss on the solution stoichiometry. Okay, so we will discuss, I am going to discuss that in part two video. All right, so that's all.